Tanmoy Biswas, I welcome you all in my channel Chemistry the Mystery of Molecules. So today's topic of discussion is polyethylene terephthalate or PET polymer. Its industrial preparation with mechanism. So you can see the structure of the polymer. So today's point of discussion includes the points why it is important, methods for its preparation, mechanism of the reaction, source of synthon, biodegradability, methods for its use, reusability, and finally should we really dependent on such chemical for our regular life. So let's go into the details. So before going to details, this is a MCQ in front of you. Which polymer is chemically most inert or chemically most stable? Okay, 4 options are provided. I request you please pause the video and write your answer in the comment box, and definitely at the end I shall give you the answer. Now, why this PET is important? PET is most common thermoplastic polymer resin of the polyester family. Why I am saying? And it is used as a fiber for clothing, container for liquid, water bottles, food, etc. Now, sometimes people say, please don't mind, polyester cloth, polyester, but this is nothing, this is polyester, because people pronounce them for their easiness. This polyester, they don't say, they say polyester or polster. So why this is polyester? Because it's a ester based polymer. In this case, polymerization is happening through this ester formation. So this is actually the ester linkage. And how esters are formed? Simply esters are formed between the reaction of acid and alcohol. So we shall learn. So whatever we use, these bottles you use on a regular basis, this is made from PET, polyethyl terephthalate and ethylene glycol. So how methods for its preparation, how it is prepared? So dimethyl terephthalate process, DMT process, and transesterification reaction. First, why dimethyl terephthalate process? Because you can see this is the dimethyl terephthalate. Since this is used for this reaction, that's why this is called dimethyl terephthalate process. When it reacts with two equivalent of this ethylene glycol in presence of basic catalysis 200 degrees centigrade, it produces this polymer. And why this is called as transesterification reaction? Because this molecule, this dimethyl terephthalate, is also an ester. And what happens? This ester is reacted with this ethylene glycol, means it's a nucleophilic addition, opens up, it comes back, and this OMe leaves. Similar thing happens for other group part also. So in this way, first it produces this transesterified products. This means this ethylene glycol derivative ester, better to say. But remember student, this is still monomer. Okay, and in this case the methanol which is produced, that is distilled out and stored and reused again. And remember, for a chemical industry, reusability is matter, because if you throw anything outside, you need to justify, because throwing any chemical in the environment will result in environmental pollution and harmful effect will be observed on humans as well as other organisms on nature. So that's why it is very important for industry. That's why if any case possible where reusing or recycling possible, industry they should definitely do that. Whether it's cost effective or not doesn't matter, but if we destroy our planet, that's the biggest cost. Now in the next stage, what happened? At 270 to 280, see the temperature is more. What happens? In this case, this molecule react, this ethylene glycol ester reacts and produces this polymer with this ester linkage. Okay, so and continuous removal of ethylene glycol. Why? And first of all, how this ethylene glycol removed? This is distilled out. How? See, boiling point of ethylene glycol is near about 200 degree. I have already discussed a dedicated video on ethylene glycol, you can see. So there's 200 degree. So what happens? In the reaction temperature is 270 degrees. So in this temperature, ethylene glycol will be distilled out, and this is actually polymer. So it is a solid compound. Since it's a solid compound, it will be remain in the reaction medium. So in this way, this polymer are prepared. Now if you look at, see, there is one ethylene glycol, there is one ethylene glycol. When it molecule attached to another one, it will remove another ethylene glycol. So in this way, ethylene glycol will come out. Now some question, that is, sorry, some point, this methanol and ethylene glycol are reused. Means in this case what ethylene glycol comes out here, distill out, that is reused further, because ethylene glycol is also a commercially important molecule. We can't throw it outside, because this, for example, this ethylene glycol, what happens, it produces for oxalic acid, which is toxic, and methanol produces formic acid and formaldehyde, that's also toxic. And compare the entropy of the reactant and polymer product. See, remember, in case of any polymerization reaction is entropically unfavorable. In this case, delta S is negative. Why? See, polymer means it's generally a solid product, and this compound, for example, this monomer, what you are observing, it's actually converting one molecule, means n number of this monomer are converted into one polymer molecule, big molecule. So that's why entropy is reduced here. Then question, why the reaction happens? Because in this case enthalpy matters. Okay, and another thing, it's an equilibration process, and what we are doing, we are distilling out this ethylene glycol from this reaction medium. Consequently, the reaction is going on the forward side because of Le Chatelier principle. If you from equilibrium mixture, if you remove the product, then the reaction goes forward the product side. Now, so in the next step, methods for PET preparation. How this it is prepared, this polyethylene terephthalate, another way. Now, terephthalic acid process, that is a esterification reaction. So it's a, you may consider it is a direct step. So it's a direct polymer preparation. How this is? Now in this case, n molecule of terephthalic acid and n molecule of ethylene glycol are reacted 220 degrees centigrade to 260 degrees centigrade. As I told, the boiling point of ethylene glycol is 200 degree, near about 197 degree, and pressure is 2.7 to 5.5 bar. Although the temperature is higher than the boiling point of ethylene glycol, but since the pressure is higher, that's why ethylene glycol will remain in the liquid form. And remember, when it is in liquid form, both reagent if are in the same phase, then reaction became easier. So after this reaction, it is produces this is the polymer. Okay, and this in this case water is produced, which is distilled out. Now recall one method for water removal during the process of reaction and what kind of chemistry is used there. One method which we generally use, that is azeotropic distillation. Okay, where we use this, actually azeotropic distillation is removal of water by using the formation of azeotrope. For example, that is toluene water azeotrope, toluene plus water. By the way, student, there are some example you can see in books, that is benzene plus water also form azeotrope. I agree, but always prefer not to use benzene when you have a safer alternative. Toluene is safe than benzene. I have already made a dedicated lecture on this topic. So this toluene water azeotrope we do in case of acetal formation. For example, like this is aldehyde in presence of ethylene glycol. What we present is any alcohol, ethylene glycol as a simplest example. This is, so this is actually acetal. Okay, since it's from aldehyde, that's why it is called acetal. So this is the application of an azeotropic distillation to remove water out from the reaction medium. Now, how this time reaction happens? See, in this case, what we are using, this is the terephthalic acid. I am not showing the other part, and along with that, what we are doing, we are giving ethylene glycol, and very drastic condition, better to say. Now in this case, what happens, this lone pair of alcohol will attack this and it will come back, and this OH leaves. So and from this part one proton leaves, and from this part one OH minus leaves. So ultimately it produces water. And along with that, what it produces? It produces, this is the CO, this part same, and this is OH. Now you can ask that, sir, why this will produce? Why? What is the driving force? Generally for esterification we use either acid or we use either base, we use either acid or we use either base, or sometimes use some other thing, or use water removal reagent. So anything you are not doing, first of all, student, check the temperature. It's very high, so under this condition water will not remain in the reaction medium, it will vaporize, or if you allow it properly it will remove. Now second thing, under this condition, drastic condition, it will not come out, but later you can separate easily because boiling point of water is 100 degrees centigrade at normal condition. Now this is point, and now say that without presence of this acid or alkali, how the reaction is happening. Please check the reaction condition. It is too much drastic condition, and under this drastic condition such kind of reactions are possible. Point number 1. Point number 2, this reaction is not stop here, it will go and ultimately it will produce polymer. Why? Because this alcohol in a similar fashion, means the reaction happening here in a similar way, this will continue, means in this way what will be the product? In this way product is this. Okay, so another molecule OH will attack here, means I am not saying same. Okay, by the way, for your confusion, let me draw another here. So this is the OH, the rest of part are same. So what it will do, these OH have lone pair, so it can attack here, it will leave. So in this way ethylene glycol will produce and polymer will form. So this is the overall mechanism for this reaction. Now the most important thing, for industry you need the proper source of synthon. It must be cheap, widely available, easy to handle and environmentally safe. All the things are important, but sometimes we compromise. But remember, any compromise along with any compromise, proper precautions are essential. So ethylene glycol is prepared from ethylene oxide and hydrolysis of ethylene carbonate. First process is known as union carbide process, second is known as omega process. I have already discussed in the dedicated video for ethylene glycol synthesis. Please visit. Now terephthalic acid, if you look at, it could be prepared from paraxylene, or this is actually a monomethyl this ester. Okay, so one part is ester, another part. So ultimately these are oxidized in terms of cobalt manganese based catalyst and produces this product which is known as terephthalic acid. And by the way, this chemistry is named as side chain oxidation. So this is a best method for one of the best method for aromatic carboxylic acid preparation. I have already discussed in carboxylic acid preparation video. There you can understand for better about mechanism. Now how dimethyl terephthalate? So dimethyl terephthalate is student and ester. Okay. Now in this case reaction of methanol, since the methyl ester, acid catalyst produces this and water, because during the esterification reaction water comes out. Now you will say that, sir, sometime before this reaction you didn't use any acid or base, you just use heat, and in this case you are using acid. Why? This is because, student, you need to consider the reaction condition. Just check the condition. 220 degree to 260 degree, this is, and 2.7 to 5.5 bar. So this is a really drastic condition, but in this case reaction is mild, carrying out under milder condition. So whenever you are doing reaction under milder condition, we need proper choice of reagent, and remember in this case we have a very big advantage, that is selectivity. So that's why we need to think many points. For example, selectivity, reactivity, what are the input cost, means under, if you want to make such kind of drastic condition, you need to make proper precaution, and for that purpose instrumental cost, production, scale up, everything you need to consider, and overall which is profitable not only for money, on chemistry, safety, everything point of view, which is best profitable, that is followed in industry. So this is the method to prepare this dimethyl terephthalate. Now the most important question, because nowadays, some days before, the Paris climate agreement happened, which is mainly about on the climate. Okay, means the climate, nature, you can say we are right now thinking our nature very seriously, and this is needed. I agree with this is needed. So another point of view of natural thing is it biodegradable, or will it get degraded automatically inside the atmosphere or nature? So actually PET is not biodegradable, so please be careful. I repeat, it is not biodegradable and stays for long time in the environment. That's why please don't throw anything made from PET into the atmosphere or environment. It will be there and it will create poison. It will show its toxic effect. And remember, humans have option that they can purify their water, they can wash their vegetables, but think for the other animals. For example, dogs, how they drink water, they take water from the pond and local places. If everything is polluted, they will also be die. Humans are the most intelligent species, so they must be responsible. They should not be selfish, and if they should be selfish, then nature will take the revenge accordingly, because in nature's eye everyone is its siblings, a dog, a human, a insect, a plant, everyone. But so if one child is destroying the others, then nature should not be silent. We consider nature as mother, so mother will take care of all of her children, not a particular children. So please be careful. I know my words are a little harsh, but human behavior or activities are really extremely irresponsible. So I am saying harsh, but in future nature will do the thing. That time it will be very difficult to accept. Now let's come to the point. Some reports are there about the degradation by microbe species of the bacterium in the genus Nocardia can degrade PET with its esterase enzyme. See, look at the name, esterase means it break ester. It's an ester polymer, that's why this esterase does. So this way you can remember the names little easily. Okay. Now, such kind of results require further studies and environmental compatibility of such kind of new species and its overall effect in the environment in short as well as long term. So that's why please don't be selfish and throw it into the environment. Maybe you will not be directly affected, but other animals. And remember, in an ecosystem, everyone get affected. You will say that instantly you will not get affected, but in future you will be affected, because the water will pollute fish, you will eat the fish and you will be affected. If a goat eat that plastic containing thing or bad water, it will go into his body, and if when you eat the meat of goat, you will be. If you say I am vegetarian, it's not my will not affect me directly. Yes, if it's mixed to the water and through the plant, it will go into the grains, and whenever you eat that, you will be affected. So no one is out of touch of this irresponsible activities. Now, it is better not to throw them into the environment, or better to send for recycling. The prime use for PET is polyester fiber strapping non-food container, which is beneficial for lesser cost, and recycled material are solution for disposal problem. What do I mean by the statement? Actually, it means that whatever PET is recycled, those are produced for low grade material preparation, and those could be used for other purposes, but please don't use for food application, because when we are recycling, we are not taking a pure thing. For example, a damaged thing having some dirt thing, etc., that is recycled, so that may not be healthy for eating purpose, but could be useful for other purposes. And if you do recycling, we will not bring or produce this chemical more and more, because ultimately we are producing it on the earth and we will dispose it, and our human race is not that much responsible. So we need to think responsibly during the production side, because if there is some less in production side, the people will be responsible, because its source is limited, so we must be more careful. See, everything is based on in market as a demand and supply. If supply is less, then demand will be more, and people cares the things which are more costly. But I know this creates lots of debate. I am not interested to go into that. My intention is to say that people will use it responsibly. So remember that the ultimate degradation product like ethylene glycol and terephthalic acid are not good for environment and for large amount of prolonged dumping. So we need to be more responsible to take care of our home earth. So that's why you should not dump. And please, I request you, because it is very risky to say anything publicly, that I am saying that product cost should be high, I am against the people who can't afford it. Is not. I am against throwing things into the environment. That is done, means whoever is doing that, I am against that. But my intention is not for that thing, that everything must be costly and only a percentage of the society will be able to afford it and other not. Please don't get misunderstood. Now, methods for reusability with chemical reaction or total glycolysis, methanolysis or hydrolysis. See, this is actually a strategy how that will help us how to reuse this. So PET into 2-hydroxy terephthalate. How? So see, this is actually again this also transesterification. Okay, transesterification reaction. So in this case, this alcohol is used. So in this way, it is converted into the monomer. Okay, just sometime before we have discussed. Now a question you can ask that, sir, we have to prepare the PET ultimately. So why we are preparing this monomer? What is the benefit? Remember, student, you are doing the recycling. So the PET which you are taking for recycling in the initial phase, this is impure, means it has lots of other thing which is not desirable. So in that case you are converting this polymer which is insoluble solid material into a monomer, and these monomer could be purified further by fractional distillation, column chromatography, crystallization, etc. processes. So in this way we will make this monomer pure. If the monomer is pure, then again the produced polymer is pure. So that's the beauty of the chemistry, in which from an old material you can prepare a new material with purity. Okay, so another thing is that PET into dimethyl terephthalate. So in this case, instead of ethylene glycol, you are using this methanol, and this methanol is doing same transesterification reaction and ultimately produce this, which will be used further in the same way. And remember that this is important for recycling thing. With the from recycling we will prepare pure material. Okay, so this is the ultimate solution. Although this process is energy intensive, but pure monomer could be gained up, so that's the advantage. And remember, we are trying to produce energy in a cheaper way. That's our target. If you are able to successful on that case, then it's not a problem. Ultimately we will get more better quality product. And purification could be achieved by method like fractional distillation, vacuum distillation, crystallization. Okay, so what is the solution? My personal opinion, we should be responsible member of this planet. We should avoid use and throw the material like PET bottles. We should avoid use and throw culture. Like nowadays we purchase a thing, we use and throw it in the nature. We should not do that. It will be better if we carry our own bottle made of steel or copper for pure drinking water purpose, because PET bottles are nowadays the biggest problem. Okay, so that's why if we make steel or copper bottle, that's better. And by the way, copper bottles are better in the point that they purify the water itself, because on copper these microbes, this thing die and water quality improves, and slight amount of copper inside the water which is coming from leaching of the surface of the bottle increases and helps to improve our immunity. It is well established. So that's why these copper bottles are very good. So, and another thing, there are some kind of steel which will keep the cold water cold or hot water hot. So from that point of view also this alternate is better. And another thing, for polyester fiber clothes, compared to that we can prefer to use cotton clothes than polyester, because cotton is grown naturally. Now you can say that, sir, we have a small amount of land, we are not able to produce enough food. So if we produce such kind of crop like cotton, where we produce food or where we produce other thing. So by the way, there is another solution in this question. It's a debatable question, we need to think more, but one solution I have discussed previously about seaweeds cultivation. They could be a nutrition rich food in our future. Actually they are by nature superfood, very nutrition rich, so we can cultivate those things in our coastal region. So that could be another option. So we need to have a debate wisely and ultimately decide. And there is no ultimate profit by destroying the environment. We need to think. We may go for short term profit, but ultimately we will not be profitable. So Earth was a better place before industrial activity, and the planet belongs to all, not only humans. So we should not consider this is our personal property. Okay, now next is our question. Which polymer is chemically most inert or chemically most stable? This is cellulose, PET, Teflon and polyester. Among them, Teflon is the most inert. Why? Because this Teflon, the structure of Teflon, if you look, it's a polytetrafluoroethylene, means this one. Okay, so this is the polymer, and in this case you can see there is either carbon-carbon bond and carbon-fluorine bond. Carbon-carbon bond is also inert, and carbon-fluorine bond is very inert, and by the way it is one of the most stable chemical bond. Okay, so that's why this is the most inert. And proof of this statement, the non-stick frying pan which we use for our cooking, we can heat, we can make food on it. Ultimately it doesn't get destroyed that much easily, although it is not 100% safe. So but still we can use it because of the stability of this bond. Another thing, because of the electron richness of this fluorine, this Teflon is also hydrophobic, means it repel. That's why you can cook without oil. okay, and that it doesn't stick. The non-stick nature comes on the because of this fluorine electron richness, it repels. So that's why this Teflon thing is polytetrafluoroethylene on Teflon is more stable, okay, and others are relatively more reactive compared to it. So this is the end of the discussion. Thanks for watching. See you in my next video.